Welcome this afternoon. I'm going to talk a little bit about time zones and calendars, and that there are a little bit of not Italian bread. All right, so hi, I'm Derek. I live in London. I work on PHP things, including the daytime extension for PHP. I like maps, I like beer, and like whiskey, and some of these things will come back during this presentation. If you have any questions, please raise your hand. I'm happy to answer them. And also, please don't throw rotten fruit at me or milkshakes. That has not happened yet. All right, so we're starting with a quiz because that seems to be a popular thing in more and more presentations. So raise your hand if you agree with the statements that flash up on the screen. There we go. Ready? Everybody ready? Sorry, I never drink coffee. I had 3 cups just before this presentation. So I'm as high as a kite almost. It's not quite that bad. But yeah? You ready as well? Quiz time? Okay. Each day has 24 hours. Who says yes? Half of you say yes. It's wrong. Not every day has 24 hours. Anybody who wants to guess when it doesn't? Go ahead. All right, that's an excellent point. Either when when you go to daylight savings time, you have 23 hours, and when you go away, you have 25 hours. So what about this one? Each day is 23, 24, 25 hours long. Who thinks that's correct? Nobody. You're not falling for it anyway. I knew that this always happens with the second question, but there are some trick ones in there too. It's also not true because there's some regions that jump only half an hour forward. Or some people change their time zones. And they jump by 2 hours. So then you suddenly have 22 or 26 hours happens. Next one. Every time exists only once during a day. And that is because? Okay. Oh, I have multiple questions. That's great. Leap seconds. Technically correct. PHP doesn't care. The other one is, of course, when you go back from daylight savings time or summertime, as some people might want to call it, back to normal standard time or winter time, as some people call it, then you have the same in the Netherlands at least 2:30 twice, right? In the UK we have 1:30 twice. February has 28 or 29 days. Who think that's correct? I see only 4 hands. It is correct unless you live in Sweden. Sweden once had a February 30th for the simple reason is that when we switched from the Julian to the Gregorian calendar, most countries stepped in one go. Depending on when this happened, the UK was a lot earlier than the Netherlands, for example. But in Sweden, what they decided to do is instead of doing one big jump, they do it gradually over the years. So they started removing leap days to do this. Then they forgot once. And instead of continuing with it, they decided, screw it, we go back to the old Julian calendar and try it someplace else. But because they had to go back, they needed to have a 30-day February once. All right, every day is 365 years. Nobody's falling for that one, right? So what about this one? Every day is 365 or 366 days? No? Why not? Why not? Everybody know? Anybody knows? So there's one time, just before the millennium, one group of islands wanted to be the first in the millennium, so they removed a day. And that year had 364 days, because then it would be the first to go into millennium. That is the jokey reason. The real reason is they were more economically tied with New Zealand, so it made more sense that they were in the same day. Everybody knows what 4/11 means. No? What does it mean? Anyone wants to guess? The 4th of November? Or the 11th of April? Or it's just the number, the fraction 4 divided by 11, right? Everybody understands what Pi Day is? Similarly. Yeah, everybody knows, but it's not really, makes no sense, right? The funny thing is, last time I gave this presentation was actually on March 14th, so I had forgotten to remove the slide. GMT is UTC. Who thinks that's right? For all timekeeping purposes that people use it, true. But technically not true. And I don't want to go into the detail because I'll be here in another hour. Time zones are always a whole hour offset of UTC. No, you see people shaking yes. Examples? India. Let's go with India. The Netherlands during the war is not true. They were still an hour off, or 2 hours, but it's still whole hours. But you're preempting some of my questions, and I don't like that, so stop it. So whole hour, no. India is an example. Venezuela is an example. A part of Australia is an example. And there's a few more. So time zones are always half an hour offset of UTC. No? Which one isn't? Nepal, yeah. That's the only one that I can... Yeah, 5:45. So that's the only one I can think of. We'll keep the comments for after the presentation. So the jump to daylight saving time is always in March. No. Oh, if you're in Australia, it's at the end of the... If it is in our spring. No. Yes, in our spring, Australia has autumn, so it jumps the other way around. It's complicated. So the difference between standard time and DST is always an hour. Who thinks that's right? Ah, one brave soul. It's not right. It's not right.
It's not right.
Yeah, but there's trick questions in it, and I'm trying to catch you out here. So there is one time zone. It's Lord Howe Island near New Zealand that only jumps half an hour forwards and half an hour back. Why? Who knows? It's a great idea. So daylight saving time is always ahead of standard time. Can you make that assumption? No? Yes? People say yes? No. Ireland's standard time is BST. It's the same as BST. So their legal definition of standard time is UTC plus 1 hour, although that is technically summertime, which is really annoying if you're a Java user, because the time zone database that PHP and your operating system, many other things uses, encodes these things as negative daylight savings time. Java's library don't understand that, so they need hacks around this so that they can still use the same database. It's kind of annoying. All right, each country has one time zone. No, that's not true. Examples? US, yeah, that's plenty. Or Germany, for example. So. China spans 5 geographical time zones. Who thinks that's right? Yeah, it's correct. For once, it's correct. Although it spans 5, it only has 1. It only uses 1, but it spans 5. Daylight saving time rules always stay the same. No, people have been caught out with that. Recent examples? Morocco changed it nearly every year sometimes. The US changed last time in 2007. The European Union is likely going to change in the next few years. Russia changes it all the time. There's so many exceptions to it. Mostly in South America. All right. Daylight saving time rule changes are announced at least a year in advance. No, definitely not. If only. Let me do this one. Also, sadly, not true. Yeah, really. Yeah, there's some countries that decide on Monday saying, oh, we should have switched to daylight saving time yesterday, so we retroactively do this. For whom is this really annoying? Except for us programmers. Which other industry has major problems with this? Financial? Airlines? Because suddenly the schedules don't work up anymore, right? So I'm part of this mailing list is the time zone mailing list, and there's actually airlines on there, sometimes announcing changes because they have been announced by the government, but some governments don't announce them to the project that keeps the rule sets for all of these changes. All right, PST, Pacific Standard Time, who thinks that's correct? It's not wrong, but it's also not the whole story. Pakistan Standard Time? Yeah, it's a similar one. Time zone identifier is the capital of a region. I haven't mentioned the time zone identifiers yet, but I'll do so in a moment. But they're not. They are usually the capital of a region, but the names are used as the city with the largest population in an area. Hence, the time zone for China being called Asia Shanghai and not Asia Beijing, which some people find really annoying because it's referred to as Beijing time in China. The time zone database tries to be non-political, but moderate success. date calculations are easy. Who thinks that's right? There are 2 people on front row lying. All right. What about this one? March 31st plus 1 month is April 31st. Who thinks that's right? One hand? How can that be right? April only has 30 days. PHP, it's also not right because April still doesn't have 31 days. What about this one? Who thinks that's correct? You can argue for it. You can argue for it. In PHP, not the case. But I have an example of that. All right. That was the quiz. Was that fun? Hopefully you got awake. Now let's actually talk about some things in PHP itself. So there are many, many time zones. A time zone is defined as a set of rules encoding offsets from UTC happening at different points in time, where point of time is usually measured in seconds since midnight 1970. Midnight 1970, January 1st, UTC. That's the important one here. You can't depend on time zone abbreviations for defining a time zone. My example with PST, Pakistan Standard Time, or Pacific Standard Time. Abbreviations do not necessarily give you any information about the current rule set. Sure. Question?
Is UTC an abbreviation or
okay, UTC is both. Okay. It is both. It is both, but it has a specific meaning for most things because everything else is measured off UTC. So it is an abbreviation, but it's not really a time zone. All the other time zones are always mentioned with region, continent-ish, / city name. Or sometimes when things get really complicated, you can see the dots that represent the cities, but if you look very closely at Indiana, there's like 8 very close together. Because parts of Indiana, the state, moved time zone depending on how close they are to other cities. And those cities might sometimes just be across the state border. And they make those decisions by county at different times during the past 20, 30 years. So the rules get really complicated there. Now, this is only really important if you also want to take care of historical time. If you want to look at current and forwards, there's a lot fewer time zones that you actually need to deal with. But if you have historical time, then you also need to take care of all the 500 plus variants that we have. And so this time zone database gets updated between 5 and 25 times a year. As I mentioned, some of those changes are very sudden, like yesterday. That's pretty sudden, I would say. Which also means that PHP releases, which has a bundled version of this database, can become outdated. And if you care about this, which you ought to do, then you either need to upgrade PHP or install a PACL extension, PHP's extension C library repository. I'm not exactly know for sure whether that's the real acronym. Provides this Dorpland database with the new rule set that you might need to use if you have to take care of time zones that have changed afterwards. And you can install it by PACL install TimezoneDB, or your Linux distribution will have a package for it. And for Windows, you can download a DLL for it. All right, so in PHP, there's a concept of having a default time zone. A default time zone is a time zone that is used when other bits of information don't have a time zone associated with it. So as an example here, you can set this default time zone in PHP INI, which you probably always want to do as a backup. I'd recommend you set it to UTC as a good backup. But you can also set in your PHP scripts with a function date default time zone set. And then you use this time zone identifier, which is documents in a big list on the PHP documentation. In Europe, you can get away with capital city. So Europe/Amsterdam or London or Oslo, what I've used in this case. In the third line here, I'm creating a new date time object, which I'll get back to a bit later. And I specify only a string with the year, month, day, hours, and minutes, but I don't specify time zone. Because none is specified, it will assume to use the default time zone, which in this case is Europe/Oslo. So what is the output of this? Oh, hang on. It should have told me the output. I might have messed up that slide. What it will tell you is the E stands for UTC offset. It will tell you that, sorry, doing the maths on my head here, it'll say it's UTC plus 1 hour, because that's what Oslo would have been December 22nd, 1978. You can also get the default time zone if you haven't set it yet and you want to see what's set in PHP INI, but the default time zone that gets. But this is important, the time zones, the default time zone is used anytime no other time zone information is present or hasn't been assigned to things. Okay, the output of the following. So what we're doing is we're using string to time, which converts a date time string into a Unix timestamp, the number of seconds since midnight 1970, January 1st, UTC. What is the output of this script? Which year, month, and day will it show? Anyone wants to guess? Shout it out. Nobody brave enough? We're scared, that's fine. I'll show you then. It actually shows you March 8th. And why would this be? Okay, I'll explain what it does. What happens? So when we convert a string in America, Toronto, it turns it into a number. This number is the number of seconds, it's a Unix epoch, the Unix timestamp. But when converting that into a date time string again, because there is no time zone information associated with it, it will use the default time zone, which you have seen in a previous slide has been set to Oslo. And when we do that, you'll see, oh, in this case London, but Oslo would have worked as well, because at that time it's already past midnight in London. So don't use Unix timestamps. Instead, use PHP's date time class. PHP's date time class will not only encode the amount of seconds since 1970, but it will also include the time zone that was present when the string was parsed. So in this case, it will use the default time zone set, and if you then call format on it, it will still continue using that time zone, so you get the expected result. The datetime object is therefore more than just a point in time. It remembers the time zone with it, which allows you to do lots of more interesting things that you can't do with just a Unix timestamp. Because the number of seconds in the datetime object is not restricted to a 32-bit range, because that limits the amount of seconds you can store from 1901 to 2038. In older 32-bit PHP installs, if you want to see a Unix timestamp out of it, you need to use the capital U format, which will then give you the string with the Unix timestamp in it, which you can't calculate with because a 32-bit system can't do anything with it. But hopefully you're not using these anymore. All right, what else can we do with the datetime class? Well, what we can do is a few things. But first, what does this mean? I know, one more quiz. What does it say? It depends, correct. That is indeed correct. What does it depend on? It only depends on where you live, right? So it could be August 3rd, 2010. How's that contrast? Rubbish. It could be March 10, 2008, or if you're in Japan, it could be 8 March 2010. So 3 options, right? You don't know necessarily. So this all depends on context, right? It depends on the country, depending which formats they use, what it is. So PHP by default, either with str2time, which you should never use anymore, and a datetime constructor, they attempt to parse a valid datetime string according to a set of rules. A slash means it will use the American form of using datetimes. A dash would use the Dutch or British one, for example. So there are a few variants, but in some cases, for example in Japan, where they do it slightly different again, if you want to convert these strings to PHP's datetime object, you need to tell the format, which is what you can do with the dateCreateFromFormat function, or what I've done in my example, use the createFromFormat factory method on the datetime class to then specify the format. And then you can use the same letters in there as you can in the formatting of normal datetime objects to then parse them according to that rule set. So what I've sillily done here is that the format I want to parse is day first, then month, then year with slashes in between. The exclamation mark means reset all the parameters to midnight 1970, midnight 1970, January 1st. which you need to do to reset information, otherwise it would use the current day and time. That might make some sense in some cases. So how does this work? So not only can you create one, you can also do a parse. So parsing will return you a structure with all the broken down elements of your string. So in this case, what would happen if we would call this with a date? The exclamation mark will reset everything to midnight, January 1st, 1970. We parse y, and that basically means read all the digits up until a non-digit. In this case, that is 6. It uses a 2-digit year, and then it turns into 2006. The star means parse all separators. You can also do a specific one if you want to do it, but the star does all of them. Do the 8 to parse the day, do the star for the separator, and then do the month, and then you have your date, which is, blanking here, April 8, 2006. So that's what you can do. And then you have your results. So after you've created these datetime objects, you can also start modifying them. So there are a few few methods with the datetime class that allow you to modify something. So when we start out on March 17, 2018, we add 2 days. We get, that's not a Monday. Typo. I don't know which one is the wrong one, but we'll find out later. In any case, you get March 19th. When we then say Friday plus 3 weeks, it interprets every element in this string as an instruction to modify the datetime. So Friday means, unless it's a currently Friday, unless the date that is represented in the datetime object is currently Friday, we'll go to the first available Friday. So if it is Monday, March 19th, it will go to Friday, March 24th, right? Sorry, maths is hard. And then it adds plus 3 weeks because that's the second clause in there. And if you do this in 2018, you will also see that now the UTC offset is certainly now, at least in London, no longer GMT, but it is BST because daylight saving time has come into effect. And PHP's datetime object will automatically adjust these things for you so that you don't have to take care of these yourself. When we then do next Friday again, we go to Friday, April 20th as normal. Yes, go ahead.
Why did we reset to midnight at this point?
Because the word Friday, or any name of a day, resets it back to midnight. If you don't want that, you use next Friday. So there's a few different ways how you can do different things depending on these goals. They are very well documented in a very complex way in the PHP documentation because those rules can be quite complicated sometimes. But that's a good question, thanks. All right, so what happens here? What happens in the following script? So I'm creating a datetime object in the TS variable. I call new, assign new to the original time plus 2 days. And what will the output be? What would you expect it to say? You go there. They're both the same, and what will they say?
April 1st or 2nd?
Shall we go with June? Okay, June 2nd, yes. Sorry, June 1st. May has 31 days. See, even I get these things wrong. It's not just you. So you get the same answer, right? And this is not always necessarily what you want. Many people don't. So the reason why you don't always expect it, if you pass a datetime object into a method, you do some calculation with that, you don't necessarily want that the object that you use to pass in there also changes in the color, right? That's a bit weird. So what it should have done, or what the datetime object should have been, is the datetime immutable class, which you can call the same method some, but it will never modify the datetime immutable object that you call the method on. It will always return a new object with a modified value. This is what datetime should have been, but I messed that up when I added this in 2004 because I didn't know better yet. I have plenty of time. But unfortunately, we can't change this because that would be a BC break, so we're not changing that. Can we get people convinced to change this in PHP 8? We'll talk about that. Well, we won't, but we'll talk about that in PHP development team at some point. So There's a whole bunch of other things you can do with the time zone database that's embedded in PHP. So let's say we have the time zone Asia-Singapore. They don't have daylight saving time at the moment anymore, although they have changed some changes during the, well, you guess it, Second World War, because they were occupied and stuff like that. Wars do weird things to time zone rules. But you can do some information with it. You can get information out of this. And not only that, you can also reattach these to a datetime immutable object, which is the one you should always be using, not datetime, to attach this new time zone to it to do calculations between time zones. So in the second example here, we create a date time zone for Pacific Honolulu, and when we instantiate the datetime immutable object, we assign that time zone to the datetime immutable object and not use the default time zone. In the third example here, if in the string there's a time zone present, it will not use the one that you add in as an extra argument. Some people argue this is the wrong way to do. Other people think it's okay. We can't change this because backwards compatibility. I am now leaning more that this is a bad idea, but it's in PHP, so we can't change that. All right, so what else can you do? If you have two time zones, as I said, you can convert a datetime immutable object between those two time zones. So when we create one in Pacific Honolulu, like I'm doing there, when we echo it, we get a name. So get time zone of a datetime object gets the time zone object, which you can then do some other things that we'll be showing in a moment. Get the name will get you the name of the time zone object. So in this case, it will be Pacific Honolulu. And we format it. When we then say, well, the object Melbourne is the original datetime immutable object that we created, but we set a different time zone with it. You will then see that Melbourne will then have the new information associated with it, but it will still represent the same point in time. So the output of that is going to be, if it is December 22nd, 1970 at quarter past 9 in the morning in Honolulu, it's already Saturday, December 23rd, it's quarter past 6 in the morning again in Australia, or in Melbourne, yes. So you can use a switch between time zones on a datetime immutable object here, which is kind of useful to use. Okay, there are 500 time zones. If you want to have a list of them, all the ones that PHP support, excluding the backward compatibility versions that are still in the database, you use timezone identifiers list, and that will, if without arguments, return you all of them. If you want for just Europe, you can specify it as first argument. So in this case, it will show something like this. Always Amsterdam is always first, because it starts with an A. It's kind of cool. So you get Amsterdam, Andorra, I can't even pronounce it, Astrakhan. Where is that? Anybody knows? No? Central Asia, that seems plausible. Yeah, it's in Europe, thanks. Thanks. I'm going with Kazakhstan, maybe. But in some cases, of course, Europe is kind of a big area, and you want to restrict it by country, and you can do that as well by using the per country argument and then specify the country code as second argument. In this case, CA for Canada, which means you get all the time zones that belong to Canada, which are in the continent of America. But, not this one, sorry. If you do that for the US, you got also one in the Pacific region. So it doesn't matter which region it is in this case. Well, for the US, you also get Pacific Honolulu, because it's part of the US, but it's not in the Americas region. Kind of useful to have. Is this enough to present a choice to users which time zone identifier to pick? No, because many users will not understand necessarily what Creston or Dawson actually mean. They might not even have heard of the cities because they can sometimes be really small, right? So the information encoded in the time zone database has comments in there too. But I don't have a slide for that, unfortunately. All right. Let's skip to a few other things that you can actually do with PHP's datetime support. So the next one is having a look at intervals. And an interval is a description of an interval between 2 points in time. And there's a bunch of different ways how you can create one. The top one, probably shouldn't use, but it's a standard, so PHP supports it. This one says here, the P stands for period, because that's the ISO 8601 name for these things. And it says 3 days and then 6 hours. So this creates an interval of 3 days and 6 hours. Or what you can do, you can create a difference between the current date time as well as the date time in the future. In this case, I've picked October 31st. And then you can create a difference between those date time objects. But it is important to recognize that the direction is important, because sometimes if you add a month to a date time, the results on the way back might be different. So the interval that you get back is the interval that allows you to go from the object that you call the method on to the object that you pass in as argument to div. So that's important to remember. And then we can display the difference by using the format method, where there's different letters for different things. So %A is for the amount of days, the total number of days, hours and minutes in this case, or if you want to break this up in months and days, which is a different thing than the total number of days, because it depends on the context, what is a month. Because 31 days can either be a month, or a month and 1 day, or 2 days and 3 days if you're in February. So there's a distinction in there that is important. Anyway, what you get out of this, in this case, you get 145 days, 9 hours and 59 minutes out of it. If I reload the slide, it is now 2 minutes less, because I spent 2 minutes talking on the slide. The last way of creating the interval is by using like a descriptive thing. A thing like next weekday, or tomorrow, or +1 day, or +15 minutes, things like that. All of these intervals can then later be used to do calculations with, which is on the next slide. So what I have here is I create a datetime immutable object for April 20, 2018. We format it and it shows February, April 20, 2018. That's plausible. When we then do next weekday, we create an interval that says apply the interval to go to the next weekday. And we apply this interval by using add, which means we'll end up at, want to guess? It's April 23rd, Monday. Right. The weekend is 2 days. That's handy. So you get a different output out. So add allows you to apply any sort of interval. Either the ones you created with like the textual descriptions, such as next weekday. You cannot use these for subtracting. Subtracting, you can only use intervals that you have created by diffing, or the ones that you do with the constructor with the funky ISO 8601 arguments. You can't use the ones that just have this non-absolute number of days in between two date times, for example. It's like next weekday doesn't work, or next Friday wouldn't work either, because how do you reverse next Friday? It's a really complicated concept. We can probably come up with a good set of rules, but it's going to be so complicated to explain, so PHP doesn't implement it. If you want to reverse that, you can write it yourself. So because of next weekday, you can also say previous weekday, and then it will do the reverse. Okay, sorry, I forgot that one. So relative time, this gets a bit complicated. So modify, instead of applying an interval, it can use this string, as she's shown you before. So say it is January 1st, 2018, and we say next month. What is the output here? What is the year, month, and day that you get out of this? I need some maths. February 1st, I hear, or 2nd of March. Anybody knows the correct answer? It's the 3rd of March. Why is this the 3rd of March? This sounds weird, but it's logical once you explain it. First thing is we start with January 31st. Next month, what it means, it adds 1 to the month number, which means you get to February 31st. That doesn't exist. 2018 isn't a leap year, so that means February has 28 days, which means that the overflow is 3 days, which means you end up at March the 3rd. Does it make sense if I explain it like this? Now, you could argue that it maybe should say February 28. But then, that isn't always correct either, right? Because that is not always what you expect, because that's not really a month. It is sort of a month. And how would you do the reverse? It's a tricky one to do as well, right? PHP adopted this rule is because PHP originally, before the datetime support was written in it, had this rule. Not only that, the date command on a Unix system also adopts this rule. Question?
Yes. Can you say last day of next month?
You're preempting me because that's exactly on the slide that follows. For most of the cases where you want to do this, you're not usually actually interested in the day anyway. If you want to do the next month, you want to know what the month after the current one is, right? Most of the time, not all of the time, but most of the time. So that's why PHP also has, I have to go through the explanation. Okay, sorry. I always pulled this one, sorry. You didn't see this, there we go. So when you do first day of next month, the answer out of this is, you want to guess? February 1st, yes. So what happens here? The phrase next month is done first anyway. That gets done first, which means it increases the month number by 2. But what first day of does, it does exactly what it says, resets the day number to 1, and only that does it do the resolving for the overflows, meaning, seriously, I clicked too quick. And in that case, you get the right date, the one you expect. Besides first day of next month, you can also do last day of next month, which would then instead, well, it's actually cheating a little bit. Because what it would do is it adds 1 to the month, as it usually does for next month. Last day of next month will also add 1 more to the month, but then sets the day to number 0. Because when it then does the overflow underflow calculations, it will then end up subtracting a day, ending up at the last day of the previous month. It's by far the easiest way of implementing that. It has to do the overflow and underflow calculation anyway, so because you also end up having to do that sometimes for minutes or hours, so because it has to do it anyway, it's a more sensible way of doing that. I have a slide for it, but I didn't include it in it. All right, so what else can you do with this intervals? Well, you can construct an iterator over a period to do calculations with. So an interesting way where you could use this for example, calculate all the first Thursdays of a month during the year, which is what the PHP London user group meets at. So a period object has a couple of arguments. So it has the begin date for the begin date time immutable object or datetime. It has the DI, the second argument is the interval, which can be tomorrow or next month or plus 4 days or plus 3.5 fortnights and stuff like that. Or you can do this very interesting or more complicated relative things such as first Thursday of next month, which is the one I'm using here. And then you can either specify an end date in the third argument, or you can specify with a number the number of recurrences that your iteration wants to loop over. The fourth argument is an option that you can use to either include or exclude the start date of the iteration as well. So in this example, if I would start at December 31st and start my iteration over it, the first datetime object that comes back would have been December 31st. The next iteration will then say January 4th, but I'm not sure whether I remember that correctly. When you use exclude start date, it doesn't do the first starting point. Now, the reason why I start the period the day before 2019 is because if you apply the statement first Thursday of next month gets done first, and the next month already ends up in January. So if we would have started in January and I do next month, the first iteration would be something in February. I haven't come up with a better way of doing that yet. So what the output of this is, we iterate over this and you get the 12 months in 2019. I had misremembered, it started with January 3rd, not January 4th. And so we have all the meetup dates of PHP London meetup, which I missed 2 days ago because I was here at a conference. Does that make sense? Very powerful, actually. I would quite like playing with this. It beats having to make your loops yourself. All right, next one. Storing dates and times in databases is a complex subject, and there are two possible answers. It depends on what you want to store. This is my take to it, and I'm sure not everybody always agrees with me here. So the first one is, and although I'm not using SQL here, it doesn't particularly matter because we're just storing data in a database. The first one is one we want to store a specific point in time in the future. For example, we are going to have a meeting about the abolishing of daylight saving time. Could be a title in the European Parliament, right? And we decide to have this meeting at 3:27, which is probably not a great time to start a meeting, to be honest. It's a bit weird, a bit of a contrived example. And we also remember that when we created this date, the ISO date is the date as it is in UTC. We remember with the time zone identifier the original time zone that we expected to set a date with. It is in this case not particularly necessary. But we set a point in time in the future only linked to the Unix timestamp, meaning it is always the exact same point in time, even if countries decide to change the daylight savings time rules for a certain country in the period between now and when the meeting happens. Now, that is annoying if the time zone rules change for the user that set up the meeting with a specific time zone in mind. So if the UK decides to Brexit and change all the time zone rules, which is possible, plausible, maybe not, possible, yes, then the meeting for the user, the point in time that for the user that sets a meeting will be then the wrong time. But for everybody else that I arranged a meeting with, it will still be the same point in time and their calendars will be correct. Now, if what you want to do is future-proof a specific date and time in your own agenda, saying in 2022, I want to have a memo in my calendar on October 1st at 1 that I need to go to get a postcard because it's my dad's birthday. You don't care whether the time zone rules change in the meantime. The only thing you care of that your notification is the exact same time in your local time zone that you're expecting it to be in. You can also use this for meetings if you don't care about time zone rule changes for other people. And in that case, what I would recommend is that you store not the Unix timestamp, but you store the description of the date and time and the time zone so you know exactly when this is. And then if the rules change, the Unix timestamp, the number of seconds in 1970, midnight, January 1st, that might be a different number, but for you it's always going to be the same time as your clock would say on the wall. So those are the two approaches. Depending on which one you pick depends on your situation. So in the 3 minutes that I have left, I can't give you the right answer there. Quick photo before I continue. Done? Okay. All right, so 2 different types of calendars. That's the last thing I want to talk about. There's the normal calendar that most of you will probably use. It has 12 months and 28 to 31 days each month. In this case, we have December 2020 and January 2021. I'm future-proofing this slide, as you can see. And then this is the normal calendar that everybody uses. But there's another calendar that is also quite a lot in use, which is the ISO week calendar, weekday calendar, which approaches this differently. In a ISO 8601 calendar type, the week calendar type, each year has 52 or 53 weeks, depending on when the first Thursday in January is. If it's that the 4th or later, that is week 1. If it isn't, it is week 53. Because the number of weeks each year is not the same, is not divisible by 7, so there needs to be a discrepancy. This is the calendar that's quite often used in like financial planning and stuff like that, or well, other reasons, I don't know. And the format for that is PHP can both parse this as, actually can't parse that because I added a D that shouldn't be there. But it can parse and read this information if you want to deal with this calendar. But it sometimes means that even though we're having a day in 2001, for the ISO week calendar, because it's still week 53, it actually belongs to the previous ISO year. So the year that you want to get out of this, in this case, is 2020, because it's week 53, and not 2021. And hence you use the O instead of the capital Y. I'm mentioning this because there's plenty of bug reports I've seen where people have used the O and getting the wrong year out of it. But it isn't the wrong year, it's just the wrong calendar that they use in that case. All right, having said that, I wrote a book about this. The book needs updating because it's written 10 years ago, but it's still pretty much accurate, just not up to date. So if you want to know more, go find this on the internet and maybe buy it. It's not that I make any money out of it, but there we go. So, thank you very much.